Alright, so this is DSK Coding Lesson 4, Inheritance and Interfaces. I just wanted to do this lesson before we start with GUI, just so you understand where GUI comes from. GUI is a graphical user interface. So what is inheritance actually? Well, inheritance can be, or polymorphism actually, can be defined as an object inheriting the common behaviors of another object, or a collection of common behaviors that are extended or implemented in a class. So inheritance has three types, or three things. There's a superclass, which is the parent class, who we are inheriting from. There's a subclass, which is the class that is inherited. There's also known as derived class, extended class, or child class. And inheritance, the most important point is code reusability, or actually any type of reusability, because it also allows you to reuse the logic behind it. That's the main purpose of inheritance. So there are three types of inheritance. Single inheritance, which means the parent, the A, which is the superclass, is extended in the child, B, which is the subclass. But you can also just keep going downwards. You can go as many times levels down as you like. You can have an intermediate class, 5 intermediate classes, 100 intermediate classes, a derived class, and so forth. If you look at the string class, every single class that we have extends the original class called object. Right? That's just a common knowledge. So then we also have hierarchical inheritance, which means that you could have something like A, which is superclass of employee, and then you could have B being a manager, C being a clerk, desk, D being a floor manager, and so forth. All right. So the other thing is abstract and methods and classes. So what abstract means is that it has to be overridden. It's basically a concept that has to be used, or a concept that has to be implemented, or a behavior that has to be implemented in the class that is inheriting it. So how do we define that? Well, we use the word abstract. So we can either have public, private, or protected abstract, void, and create employee. As you can see, it has no body. An abstract class will never have a body. An abstract method will never have a body. If we have an abstract, you must call abstract in the class up here. Okay. This means that this class may not be implemented directly using something like employee is equal to new employee. Cannot be done for an abstract class. It cannot be instantiated. It must be instantiated through another class which either extends or implements it. As you can see, this is how we override. We use the @override notation. Over here, public abstract void create employee. Then it would be @override public void create employee. And then we can do the employee creation object or method. What is an interface? An interface is just a method or function which has to be overridden. So you can have as many interfaces as you like. There's a theoretical limit in the actual class, but you'll never actually hit that. And remember, they're all going to be public. We'll understand more about this when we actually implement this interface. So I've started a new project called Lesson 4. And the idea behind this project is just to make it like a small store, and all it has have 5 or 10 products or something like that. And then all products will have something like tables, computers, or something like that, whatever we come up with. And what we're going to first do is we're going to create a Java class, and that Java class is going to be called product. Actually, no, let's make an actual product, and let's call it chair. And what this chair does is it has resale value, so let's put a private double sale value, or sales price. And we're going to put another private double for bought price or something. Bought price. That's how much we bought it for. And that's it. So now we have to be able to instantiate that chair. And it has to have a sale price, double sale price. Sorry about that. Double bought price. And then just this dot sale price is equal to sale price. And this dot bought price is equal to bought price. Okay. And we want to make our getters and setters, so I'm just going to use the insert option, which is Alt and Insert, use getter and setter, and then you can tick which ones you want, and we can generate that. It'll automatically get them for us. So that's great. So let's make another product, and let's call this a table. Now what this table does is it has exactly the same stuff as this one. The only difference being that this is a table. Now, as you can see, that is kind of duplicated code, isn't it? I mean, we have the sale price, set sale price, get quote price, and set quote price. And it's all exactly the same stuff. So what inheritance allows us to do is we can actually set a type of class, and all this class does is it contains a product, or it is what a product should be. So we're going to make a Java class called product. And what product does is it has all of these variables. And instead of being table, we're going to make product. So we have duplicated code again. And we're going to remove all of this stuff here. All of this stuff here. And we're going to use the extends keyword. And we have the problem here is we need to actually have, we call the super, which is the sale price and the quote price. Now, what does super do? If we actually go and Google it quickly, super Java, is that it calls its parent, which we call the super class, parent constructor with no arguments. We can then use the actual arguments in it in order to call the constructor. If we call it now constructor, super, sale price and quote price, will be the same as though we actually wrote this. Super is calling exactly this method for product with sale price and double price. And then we can continue on downwards. So one of the things we can now check is if we create a table. Let's create a table over here. Table equals a table. And the quote price is 110 or something, and the sales price is 130. Let's use table dot get quote price. And we can actually, let's print that out only for now. We don't need to see it. Now if we run this, for a second, this is our quote price of 130. But this method doesn't exist in here, does it? Well, the extends keyword brings all the methods that we put in product and puts them in table without us having to duplicate the code, because the logic and so forth and all the methods of how it does it is exactly the same. So in this chart, we can also remove all of this code, and we can extend product and call super sale price and quote price. Oh, extends, sorry. And now we can have the same thing for our chair. So we can now have all these products will all do exactly the same thing. Now, one of the great things about that is that we can use an array list. Remember, an array list can contain as many objects as you like, and we can actually make an array list of these parent object, or the super object, sorry, that has all our products. And we need to import that. Alt Enter, add import, and we can just add a new table to it. And sorry, not T product list, just product list. Then we can add a next chair of 110 bucks. I'll also make it 150 bucks, a very expensive chair. And then we can print them all out. Print each iterator, sorry. Let's just do it like that then. Oh, sorry, wrong language. This is a product, this. And then we can just print out each product. So I don't know, get for price. And run that. 130 and 200. 130 and 200. So we can have lots of objects that are all of the same parent type, and we can put them all inside the table and chair, as long as we call a method that only exists for product. So it must be one of these methods. So say a table has something special and has another special attribute, and let's say it's called dimensions or something, which is a private height, which is equal to, I don't know, 1 meter or something. And it has a private width, which is equal to 2 meters. And this is public, and then let's have our getters and setters here. I'm going to actually write them. I think we've gotten to that point. And we can get our height and width. Now, chair doesn't have this. Now, we've actually hard-coded it for now. We could also put it in here, and we could be like height and width. And of course, these are both integers. And we can do this dot height is equal to height, and this dot width is equal to width. And we can remove these settings. Sets. And if we check over here, this will not be plain. So we can have to set the height and width by 1 meter. And now if we try to do it at each product item, and we want to get its height, this won't work, because the type is incorrect. You cannot get that table method from it cannot get this get height from products, because it thinks it's still a product, and the product does not have that method. So what we can do though, let's say if we have this and we want to call the get height, we can make it so that it checks if product is instance of table, if I remember correctly. Instance of, sorry. Then we can call products dot get height, because it's explicitly a table height. And we can print that out. Of course, this is not a very good idea if you actually have to, if it has to be something individual where you don't want to be able to call it, or you want to be able to, if you have all these product items and they're all have separate methods and all exactly the same, then it's not a good idea to group them under an array list or product list. It's an inherently flawed idea. You shouldn't have to be able to get height. It should be a product type. All products should do that. All products should have a height. So this is not a very good method or a good way of logic. That's actually a flawed design, I would say. Of course, there are always special cases. Example, I don't know, in our case, only heights have tables of height. What if it's not a product that has height? What if it's a software product that's selling Office 2016 or something, then it doesn't have a height? So that would return a null value because it doesn't exist. But then you're putting in values even though there shouldn't be. And then you could have different product lists. You could have your physical and your other ones. You can just use a method to override. Now, currently there's one problem though. I can call product and I can do product is equal to new product, which doesn't make much sense because a product should not be able to be called. That's why we should actually make it, sorry, this here. I'll have to put in a value. And if we print this out, this is actually a valid product. Product.get bought price or something. If we print it out, $130, which is not a very good idea because a product shouldn't be able to exist as a product. It should be a chair, it should be a table. You cannot have a product that's just a product. It doesn't make sense. Product stands for something else. It's a blueprint for everything else. So what we do is we call it a public abstract class. And abstract class means that it cannot be instantiated. So it cannot, as you can see here, cannot be instantiated. So we're not allowed to do this. We can call all instances of it, like table, which implements product or extends product, but we can't directly call it like that. Now, let's say that we have mass in South Africa, right? But all these chairs and products and so forth currently don't have that. So one of the things we can do is we can create an interface that does that, does make sure that you have to have that, or have to have the ability, or have to have the method that deals with that. So we're going to call it that. And what this is a public interface called that. And in an interface, everything is automatically or explicitly or implicitly declared as public, which means that we don't have to write that it's public, it's automatically public. In Java 9 onwards, you can actually have private in here and protected. Currently, you can't do that. It's not possible. You have to have it as everything in here is public, so everyone can see it. This is the reason for this is because it's used for APIs, things like calling servers or whatever, because an interface is a grouping of things that should be able to be called directly. Okay, so one of them we're going to call return VAT or something like that, or calculate VAT. Let's call it return VAT for now. And this is double and return VAT. And this is now a method. And currently this does absolutely nothing. So we can make it so that, sorry, not sure, source, not history. We can make sure that this implements VAT, sorry. And if we check here, if we call, this does not actually need to be overridden because it's not abstract. All this double return VAT does is absolutely nothing currently. So let's print out return VAT. Let's get the product list, I'll get the first item, and we're just going to return VAT or something. Was it? Return VAT. Return VAT. That's what we're going to do. And currently that method does absolutely nothing because this is an abstract method that is not implemented. Now, and this here does public void double return VAT. And we need to add the override notation because it's so this forces us to use the return VAT value, which returns this dot sale price times 0.15 currently. We're hard coding it for now, it doesn't really matter in our case. And yeah, so now we can get the return VAT. If we call this, it gives us 16.5, which for our 130 chair, let's just use a calculator quickly. 100 divided, well, 130 times 0.15, oops, sorry, which is 19.5. We check our output, that's 16.5. Sorry, did I make it? Sorry, this is on the board price, not the sale price. Currently, we're having the board price second, which is actually our sale price. So let's just, we need to actually swap these around, sorry. Mistakes that you notice very quickly. Board price, sale price, and then the chair is also incorrect because the sale price should be second as well. So let's just and that should also be swapped around. Mistakes like this do happen enough. That's why it's good to check your logic afterwards to see if you actually made a semantic error. And these two should also be swapped around. Alright, so now if we check here, it should be save 110, board price, sale price, that should be on the 110, which is 16.5, 110 times 1.15 is 16.5. Alright, great. Let me check here. All this does is forces that we have a return VAT method that has to exist. So every one of these has, or product has to implement this. So what about an employee or something? Let's make an employee class. And the employee has to implement VAT. So what does that mean? So you have to implement the stack. And that means that the employee has a salary, which we're going to call private salary double. So I'm getting used to Scala where you declare the type afterwards. And then public employee just has a salary, double salary. One thing you can do in order to speed this up is you can use alt insert, use a constructor, and you can implement one with that variable. So you just click that and click that, then we have that exactly done. And this return that, all this does is it returns this dot salary times 0.15. Now we have the VAT calculated. So if we create an employee as well, or we want to add an employee, of course we can't add it to the product list dot add new employee. That doesn't exist because it's not he is not of type product. Error. No suitable method found for add employee. Method collection add product is not applicable, which means that our employee is not of type product. If you check on share, it extends product. All right, so we can then make our employee in P1 or something is equal to the employee, and he makes up the products. And then we're going to print out our employee one dot return to that of $500 and $75. Very sure about that one right this time. So what does this allow you to do? Well, if you want to create something like, let's say, a game that is a bit more complex, where you have 5 characters running around on the screen or something, then you could just make every single character inherit from type character, or the class, abstract class character. And then you could make something like move left, move right, or something like that. So let's make an employee, just as a dumb thing, have an actual position. Let's say he's currently X coordinate or something like that. X coordinate, which we can have there, and we'll also have a Y coordinate. So X, Y, and then this dot X, and this dot Y equal to Y. And all employees will have a position. All have a position. And they're all going to be able to have public move int X and int Y, which will just increment X and Y by the amount. So this dot X is equal to plus equals X. And this dot Y plus equal Y. And public void. Move. Okay. But you can also make this abstract to force something like this. We could also create something like, we could make a class called movable or something like that, so that it actually has something like return VAT, because VAT does not only apply to employee and products, it applies to anything that has to deal with money, basically. And employee shouldn't actually have return VAT. It should be like return income tax or something like that. Anyway, so public void move, and then they can have a position, and we can also have like a starting point, public void starting point, which is actually already done in our constructor up here. So then we could just move the employee, P1 employee, P1 is equal to the employee, and he starts at 0, 0. And all we want to do is print out. Oh, sorry, we need to give him a salary as well. Should remove that for now. And all we're going to do is we're going to print out EMP position, and we're going to move across. And we're going to move them on the x-axis by 1 and nowhere else. Move that over there. And we're also going to have to create a way of fetching that. So get position for a public string get position. And this won't actually take anything. This returns x, which plus x, this x plus y, this y. And then this will do is do empty1 get position. And let's run that. So right at the beginning, let's just get position here before he moves, and then he moves somewhere. So first the x coordinate is 0, and y coordinate is 0, x1, and y is 0. Why is this important? Well, if you want to create a game or something and you want to actually map them on the screen, it will be x and y coordinates. So where in position on the screen they are. Right. So I'm going to give a task in our first lesson when we get back for this, but I'm not going to add it on this video for now. Thanks for listening. I hope some stuff made sense. Maybe you can think of ways to implement this or to create something. What you could do if you wanted to, you could create like a small store, have a couple of products in there and see how it goes.